Okay, I'm Dave Smith, teaching a pre-calculus course. And I'm going to give you an overview of what we do in this course, why we're doing it, what to expect. And then I'm going to give you some of the very first specifics. And the very first specifics are something we're going to really work to completely master in a short time. This is doable. All you have to do is practice, but not everybody wants to practice even though their grade is on the line. So we have to learn what it means to focus on a topic and to dedicate the time it takes to master that topic. And these first few topics are really fundamental in the course. The whole course is built around them. And they're not that difficult to master. They don't take that long, but it does take practice. And we have to understand the need to practice, to do the homework, to engage ourselves in the course from the very beginning. So here we go. Pre-calculus is mainly a study of functions. And we have certain functions that we build the entire subject on. And also, almost all of undergraduate mathematics is built on those functions. So, here we go. We're going to draw some pictures. Okay, let's draw a little rectangle here because it's easy to construct these things in a rectangle. And for reasons that I'll explain later, we'll put a red dot in the middle of the lower edge of this rectangle, and an X up here and an X up here. And then I'm going to draw a smooth curve. Comes down and just touches that thing and goes up here. Okay, this we call the squaring shape. Now, why do we call it the squaring shape? I'm not going to tell you. I'm going to show you how we construct this thing. After we construct it, then we'll put some numbers around it and we'll figure out why it's called the squaring shape. But in the meantime, we're not going to use any numbers. We're going to construct this thing without using any numbers. Okay, now there are actually 5 fundamental shapes, and there are actually a couple more than that. But I'm going to start out with 5. Here's one. It starts just a little ways above the lower edge on the left edge of the rectangle and goes up to here. Sort of like this. Now that curve kind of looks like half of this curve, but it's going to turn out that this curve has very different characteristics than this one. And this is a different kind of a shape. This is called the exponential shape. And then we have one that's a little bit different in nature, more different from the other two, each of the other two, than the other two are from the other of the other two. I think I made myself a bad sentence there. And to construct this shape, I'm going to do this. Incidentally, there's a red dot on this one, same as here, middle of the lower edge. There's a red dot on this one at the middle. And I'm going to divide this thing up into 4 equal squares or rectangles, because these things don't have to be square. You can make them pretty much any rectangular shape you want, but squares are particularly useful at this point. So we're going to kind of make it square. Okay, so the red dot's at the middle here, and we start at a point somewhat below the horizontal center line on the left edge, and we move to a point an equal distance to the left of the vertical center line on this edge, and then we draw a smooth curve that looks something like this. And up here we do the same thing. And we get what we call the reciprocal graph. Yeah, well, there are 2 more. this graph has a red dot in the lower edge. Red dot's real important, but we haven't seen why yet. I'm gonna draw a vertical line. I didn't quite divide the thing in half. I kind of slopped it up, but that's okay. It's not a terrible thing. But we do want to do it as accurately as possible because these graphs are very useful for making estimates. Okay, so what I do now is I start down here. Now, just, you don't have to remember this, but you see that this point is a little bit above the lower line. This point is a little above the horizontal center line. Matter of fact, this point is twice as far above this line as this one is above this line. You don't have to remember that because when we learn to construct these, it's automatically going to happen if you follow the algorithm for construction, and they're easy algorithms. You just have to practice them. Okay. So here we start at the same point we do here, turns out. Although this graph is not related to this one in any significant way. It's related to this one in some ways, in many ways, as a matter of fact. Okay, so we do that, and then we make a point to the left up here of the center line at equal distance, which is half the distance of this one, or this one, or this one, or this one. We then take another point to the right of the center line and a point down here. And these 2 points are symmetric with these 2 points about the center line. Okay, each one is like a reflection on the other side of a mirror with respect to the center line. And then we draw a curve, and it's hard to get the shape of this curve right, which is why we're going to construct it. But the curve starts out pretty flat, and then it goes up really steep. And it comes down really steep, but then it gets real flat. Okay, and there's the curve. And this is called the reciprocal square. Now, I've already made a mistake, and I'm going to make a couple of simple corrections. It'll just take short time. I'm calling these graphs here and here, and I started calling them shapes. And I want to continue to call them shapes. I don't want to call them graphs, even though they are graphs. They're not really graphs until we put a scale on them, and we don't have any numbers. We don't know what numbers go with what positions. And if you don't understand what I just said, that's okay, you will. This is the reciprocal shape, and this is the reciprocal square. Sure. And finally, we're going to have the cube shape, the cubic shape. I'm going to call it the cubic shape, because it's not the shape of a cube. Now, the cubic shape is often done not on a square, but on a rectangle. It's a lot higher than it is wide. It can be done on a rectangle of any shape. The rule is going to work for a rectangle of any shape. And right in the center, I'm going to put the red dot. I'm going to put a line here and a line here. Now what we do is we start at the lower corner. We're going to go through the red dot and then up at the upper corner. But the way we're going to do it is we're going to start out very steep, and then we're going to get very flat as we go through the red dot, and the red dot should have been over just a little bit the way I drew this. Or maybe it should have been closer here. Still, that's somewhat close to the shape of the cubic function, the cubic shape. Okay, so we have these 5 graphs, those functions, and some extensions of those functions, and some combinations of those functions, and some inverses of those functions. Give us all the functions that we use, almost all the functions that we use in undergraduate mathematics. That depends where you take it. I mean, some schools go pretty high into abstract mathematics in their undergraduate programs. Okay, so there we have it. We have these shapes. Now I'm going to proceed to show you what you need to know to be able to construct the shapes. Okay, make sure the board's visible. First thing we do, take 2 points. This point's our target. This is our starting point. We go halfway from the start to the target, halfway from that point to the target, halfway from that point to the target, halfway from that point to the target, halfway again. And now my chalk is too blunt. I can't make any more dots without running these 2 dots together, because the next dot would have to be in between these last 2, halfway between. Okay, so these things kind of bunch up. We start here, we'll go 1, 2, 3, 4, 5 steps, and we're done. Now, if you have a sharp pencil, you can probably go 7 steps, maybe even 8 if you have a sharp enough pencil and a good eye. But there's a limit to how many of these you can actually draw on a piece of paper. Theoretically, there's no limit to how many times you can go twice as close to a point. Okay, so if we keep doing this forever, we're going to get, well, if we keep doing this for, you know, 1 trillion years, we're going to get real close to this point. It won't take but less than a minute, making dots at the pace I was making them, to get within an atomic radius of this point, where it's not even physically possible to make the point. All right, but theoretically, this process goes on forever. And I'm going to introduce a term that we'll use a little bit in this course. If you have a calculus course in your future, you're going to use the idea a whole lot. And the main point is the limiting idea, the idea of a limit. This point here is the limit of this process. You never get to it, but you approach it closer and closer, as close as you might wish if you make enough steps. If you want to get within an atom's width of this point, assuming this is really a point, it's not going to take you long. Now, you're not going to be able to do it because you can't see anything that small, and we can hardly even manipulate objects that close. Okay, that would get pretty close with electron microscopes and stuff like that. But we don't have those. That most of them, some of you probably have one of them. Not many of you. Okay, so that's an important idea, and it touches on the idea of a limiting point. Now, a limiting point isn't all that important for the graphs that we're going to construct, but when we start to extend them, the idea of a limit is going to become important. And it's a central concept in calculus, so we need to talk about it a little bit, which is why I talked about it right here. Okay, well now, we want to extend this idea to our rectangles. Now, I'm going to say we start at the top of the rectangle, and our target is the bottom edge. So the start is the top edge, the target is the bottom edge. We go halfway from here to here. Where's that? Well, we draw a line. I'll draw a dotted line. Pretty much through the middle of the square. Then we move twice as close to the bottom. Okay. Now, if we do another line twice as close to the middle, or twice as close to the target as the last one, there we have it. Now, what we've done first, we subdivided the first rectangle into 2 smaller rectangles. And then we took the lower rectangle and divided it into two smaller rectangles. So those smaller rectangles should be equal. I didn't do a real good job of that. This one's a little wider than this one. This line should have been a little bit lower. Unfortunately, I'm looking at this from a strange angle. That's my excuse, but it really shouldn't be one. I've been doing this for a long time. Well, we can continue this process. How long can we continue it? Well, until we run out of room to make the lines. And that's not going to take long, especially with a piece of chalk. So here we go. Here's a third line, twice as close as the last one to the target. Here's a fourth line. I'm being kind of careful here, because I want to get 5 lines in. It's, you know, I'm not doing a great job of getting twice as close, but it's kind of that way. And another line. Okay, now I can't get a 6th line in there. You probably can with a pencil, even a 7th, if you're careful. And if you make the square or the rectangle pretty much fit a full page of a full-size notebook paper, you'll have room to draw at least 6, 7 of these lines. And of course, they get very, very close to the lower edge. All right. So here I've got 5 lines. And I say that I've subdivided the rectangle from, oh boy, take a smudge length that happens. Subdivide we say we subdivide it in 5 steps. Now with some of our rectangles, we've got to subdivide it an unrealistic number of times. You can't actually draw all the subdivisions. You'll see how that works out, but we can deal with that. Still, you should be able to draw the 5 lines. If I can draw them by hand on a chalkboard, reasonable accuracy, you can do a good job with your pencil. Okay. Now, this is one of the things you've got to practice till you are doing it pretty well. Okay, how long is it going to take you? How many times do you have to practice this? I don't think you have to practice this for more than 5 minutes before you're pretty good at it. Now, when I say practice it, a lot of times you're just going to slop down a graph. So you ought to be able to slop down this picture in 20 seconds or less. Okay. So I would recommend that you practice it until you can slop this down with a reasonably good picture in 20 seconds or less. Doesn't have to be perfect, but the point's got to keep getting closer and closer together. Okay. Now, this is what I mean when I subdivide. I subdivide everything in half. So I didn't use the word in half because we could subdivide it in thirds. I go twice as close to this edge as to this one, and then twice as close to this edge as this one. And I wouldn't be able to do as many lines, but I could do it. I'm going to leave out the subdivide in half. When I say subdivide in this course, unless I say otherwise, I just mean divide it in half. Okay. Now, that's not a difficult idea. We do it in class and people learn to do it very quickly. They don't always learn to do it fast, and I tell them, okay, you got to go home and learn to do this fast. Go home and practice it. Take 5 minutes and practice doing this quickly until you're pretty sure you can get it reasonably right. Okay. Just reasonably. It doesn't have to be great. But quickly. Some people are just too meticulous to bring themselves to do that. It's going to take them more than 5 minutes. Okay. But they need to get down where they can slot this thing down. I'm saying in 20 seconds or less. And you should take a stopwatch and do that. Okay. Or, you know, look at a clock with a hand, you know, second hand, and they still make those. I don't know how people understand circles without looking at clocks going around. I mean, yeah. Okay, okay. So anyhow, there we got it. Okay, well, that's actually pretty easy. So this shouldn't be a stumbling block. Do this in 20 seconds. Okay. Now, there's another way to divide things up. And this is what we usually do with vertical lines. Now, we're going to divide these up with both vertical and horizontal lines. But we're going to do this. Okay. This is subdivide top to bottom. I'm going to call this I'm going to center divide a rectangle. Okay. Now, center divide, well, I thought the way I say this is we start by dividing the rectangle in two. Now this side is too big there. Okay. And if you're not doing any worse than I'm doing here, it's okay. If you're not doing quite as well, but kind of close, it's fine. If you're really, if these lines are equally spaced instead of being twice as close together at each step, you're not doing it right. Okay. Center divide, a rectangle, okay? No, it's just a rectangle, okay. And there's not a big space in there. So we divide it in half. Well, what we do then is we're going to divide each half in half. Okay. Now, don't pay any attention to the screens you hear. There's an EMT class going on. I think they're doing some sort of simulation. And what we're hearing right now is really minimal compared to some of the things I do. And I love EMTs, they were there when I needed them once time, about 10 years ago. So they serve a great purpose. So I'm not gonna object. It's a little inconvenient that they're right across the hall. Sometimes you know, it's usually very quiet. Good guys and women. Okay, so here we have a subdivision. We've divided the rectangle in half. We divided each half in half. Now what we're going to do, if we go another step, sometimes we stop right here. That's as far as we go. And we pretty much, at the beginning of the course, to do these shapes, okay, and like you say, if we're doing the exponential shape, this is all we need for the vertical lines. If we're doing any of the others, we need more lines, okay? Don't need that many more. So what we do is we take the rectangle closest to the center, which would be on the right would be this one between here and here, and we divide it in half. And then we do the same with the rectangle closest to the center on the left. Now, what I often see is people will divide this rectangle in half. No, they'll divide this rectangle in half. No, not to construct the basic shapes. Okay. There are times when we would want to take those divisions, but that's okay. All right. Now, we could also center divide the rectangle. Be specific. Here we've divided it with vertical lines. We can also center divide it with horizontal lines. Okay, well, if we center divide it both ways, and I think you could do that right now. If I just said, draw me one, center divide it with horizontal lines. For in class, I might, and very well might ask people to do that, give them a minute and walk around, see how people did. And then decide what I need to tell them next, based on what I see. And that's how I run class. And if you're in my class, you'll find that out. Okay. For the reciprocal shape and for the cubic shape, we're going to use a subdivision with horizontal lines, a center subdivision with horizontal lines. Okay. And I'm just gonna sketch that up here. Okay, so here's the center. We divide each rectangle in half. And then we divide each of those rectangles in half. Now, sometimes when we want to look at limiting values of functions and stuff, we divide a lot more than this. But for these basic shapes, that's it. We center divide. With horizontal lines, okay? And that's what we see here. Just like this one, if we flip it, rotate it 90 degrees in either direction. All right. So this is all we need to know about how to divide up a rectangle. There are only three things you can do. Three things you need to do. Divide upward toward lower by whatever number of steps. Center divide with vertical lines, and I'm going to call this 3 steps. First step, we divide the rectangle in half. Second step, we divide each of those rectangles in half. Third step, we divide each rectangle or the center in half. If we continue to divide the rectangle closest to the center in half. You can imagine what that would look like. You might even want to sketch it because we will do some stuff with that, but not right away. Okay, so there's your process. Now, what do you get if you combine these? Well, I'm going to just kind of slop these down as examples. Okay, well, we're always going to center divide the rectangle in some way with vertical lines. And we're always, you know, I keep looking at this. I suppose say lines and it says times. It's lines with an L. Apologies for the confusion, everybody. Okay. We subdivide with vertical lines. And again, this rectangle is a little too big, and this is probably a little too small. This one should have been over a little ways. These two aren't too bad. This is a little narrower at the top than it is at the bottom because that line wasn't completely straight. That's pretty much okay if you're just doing ballpark estimates. Okay, and you're going to draw a lot of these, almost every day you're going to draw some. Okay, so we just center divided in vertically with 2 steps. Remember we said this was 3 steps, and I didn't ever write down 3 steps. I said it, I thought I'd written it down. I tended to write it down, but okay. Center divide, vertical lines, that's 3 steps. 2 steps. Here, center divide 2 steps. And then we I didn't give this a name. I'm going to say use the word edge divide here. Five steps. And that's what I mean. This is what I mean when I say this. Okay. Not difficult terminology to get used to. I'm abbreviating vertically VERT, okay, horizontally HORIZ. 5 steps. So here's 1, 2, 3, I lied, I'm only gonna do 4 steps. Okay. So that's what one of the possible divisions looks like. There aren't that many. Okay, this one, I'm just gonna show you. I can use to construct the exponential shape. And when I sketch the exponential shape, I said it looked like this. All right. If I want to make a good graph of the exponential shape, I do this subdivision. Then I start at this point, which is on the left edge, on the very first line above the lower edge. It's not at the lower edge. People will do this. And another thing is, in my class, when I give a quiz in this, these have to be perfect. In other words, you put this one on the lower edge, that's 0 points. Okay? Even though you did everything else right. I'm not going to do these partial credits because I want you to get used to the idea of being precisely right and getting it right and practicing until you do. You won't be able to do that with everything that comes up in this course, but you can certainly do that here. 90% of my last class succeeded in this by the second day of class. Well, the third day of class. First day I showed them how to do it. Second day they came in, some of them had mistakes. They were not too bad, decent attempts, but they hadn't practiced enough. And then I said, go home and practice, do this right next time. And 90% of them did. Okay. And this is kind of precision. And then those class ended up doing quite well. Whether that was a reason or whether it was just, pretty good bunch of students, I can't tell you. But I think this had something to do with it and the idea of learning to do things precisely. Okay, so we start here. Now, the rule is right down start. Left edge. First line. Above. Lower edge. Then over 1. Up 1. By that, I mean, on the left edge, we go over 1 line, that's to this line, we go up 1 line, and there's our point. Then we go over 1 and up 1, there's our point. Then we go over 1, up 1, there's a point. Over 1, up 1, there's a point. And then a smooth curve. Okay. Now, as kind of close to the graph, that one gets a little too steep, but actually, since this rectangle was a little wide, this point should have been a little to the left. Probably should have gotten steeper up there. Okay, so maybe closer to this than this, or maybe something in between would be the perfect exponential graph. If you draw the thing carefully enough, it's really easy to get a nice smooth curve. It's the easiest graph to draw, which is why I demonstrated first. Okay. Okay, well, again, that's one way of dividing. Now, quickly, another way of dividing, and I'm not going to write out a lot here because I don't want to make this video too long. Okay, what am I doing here? Couldn't take you any longer than that. I'm using chalk. I've been a little slower than good pencil. Okay. After you've done 10 or 15 of these, you should probably be doing that quickly, unless you're being overly meticulous. And especially in class, we don't want you to be overly meticulous because then it slows everything down. Okay. At home, you can be as meticulous as you want, but you have time constraints. So learn to accept a little bit of imprecision. If you can, some people just have to have it precise. That's okay. Just takes a little longer to do things, but it comes out really nice. And I like seeing it. But it's not required. Okay, so here we have it. Now, what did I do here? Well, same thing I did here, but one more step. I mean, this line and this line are the same as this line and this line, then I just subdivided once more toward the center. Now, I'll just abbreviate this. I vertically center divide 3. Vertically center divide with 3 steps. First step, middle line. Second step, divide these 2 rectangles in half. Third step, divide each of the rectangles closer to the center in half. We don't divide this one in half. We don't divide this one in half. It's this one and this one, the ones closer to the center. Okay, then same thing I did before, but one more step. There's 1, 2, 3, 4. And the last one's kind of hard to squeeze in there, but you're gonna do it 5 steps. Okay, so horizontally, edge divide by 5 steps. Okay. Well, then what do we do? Then upper left. By that, I mean, we start with the point in the upper left-hand corner of the rectangle. And if I write this out, I'll state that, put that in the words, but I'm not going to take the time or take the board space to do that. Start the upper left, okay? And then over 1, down 2. To the red dot. Now, the red dot for both this one and this one is at the center of the lower edge. So it's on the center line on the lower edge. Let's see how this works. This means I go over 1 line, down 2 lines. Then over 1 line, down 2 lines. Then over 1 line, down 2 lines, and the second line I hit is the lower edge. Because I've got this 5th line in here, I can go over 1 and down 2. I don't mark a point on this last line. I don't mark a point on this line or this line. I go over 1, down 2. I'm always skipping a line. So that last line's in there just so we can skip it. When we do more subdivisions where we maybe got 9 lines here, okay, well, maybe you can draw the 7th one, but you're not going to draw the 8th and the 9th. There isn't going to be room on any reasonable graph unless you're working on table size graph, okay? And in that case, we say, well, those 2 lines are really there, but we can't draw them. They're virtual, okay? We got 2 virtual lines that is so just so we can skip it, or maybe 3 virtual lines so we can skip it. Okay, it depends on the graph we're drawing. Okay, well, anyhow, okay, now we're to the red dot. What are we going to do next? There are 2 ways I can state this. You can say, okay, just put the points symmetric about the center. That means there's going to be a point here with the same distance to the right of the center. The point on this line, same distance to the right as this one is to the center. And this one will reflect through the center and end up at the upper right-hand corner. People seem to have a pretty good handle on left-right symmetry and top-bottom symmetry. So that's not a bad way for me to state it. However, I'm going to officially state it. Then over 1, up 2. Now, implicitly, we stop when we get to the end. When we get to a boundary of the curve, we don't of the rectangle. We don't go outside the rectangle at this point. It's pretty easy. There's some simple rules for going outside of the rectangle. We'll see them later. We're not going to worry about them right now. Okay, so we go over 1, up 2. Remember, there's that lowest line there that you can hardly see. Sometimes there are virtual lines that you have to just imagine are there, then you got to skip them. Okay, but there it is. And then over 1, up 2. We go over 1, we skip this line, we go to this. Over 1, up 2. And over 1, up 2. There it is. And now we draw the smooth curve. I won't always write down the step of smooth curve. But we make this curve as smooth as we can. I could mathematically define what we mean by smooth. The official mathematical definition requires that you understand enough calculus to understand the definition. So I'm just gonna say, make it as smooth as possible. Don't wobble around, don't put points on it, don't make sudden changes in direction. So this doesn't come down to a point here and then up here. It has to smooth out, it has to be smooth when it gets down here. There it is. Okay. So that's the square. Okay, so this is the, we'll call it the toolkit exponential shape. I don't call it a graph yet because we don't have numbers. We don't need numbers. We never needed numbers to do this. The numbers follow from the graph, as you'll see. The graph doesn't follow from the numbers. And why am I doing this? It's because usually at the beginning of a pre-calculus course, you learn what numbers make these graphs. Okay? There's nothing wrong with that, except that numbers are just things that come out of the calculator to many students. We need to develop a sense of what the numbers mean so that we're not going to start this course with numbers. We're going to start it with pictures and shapes because, among other things, the numbers lead you directly to algebra. And what we're saying, especially in this post-COVID era, is that people come out pretty inadequately prepared in algebra. And they immediately hit stumbling blocks. We don't want people to hit stumbling blocks at the beginning of the semester. So we smooth things out with these nice smooth graphs. And we introduce algebra gradually so that people can refresh the algebra they know. Okay. Hopefully that works well for them. Okay. Well, there are more shapes. I'm sure you're anxious to see how we do the rest of them. So let's just do it real quickly. Okay, the squaring shape. I'm sorry, we got that, the reciprocal shape. I'm just going to draw it. I'm not going to, and I'm going to say what the rules are. By now, if you understand what's been said, you'll be able to understand the words. I didn't want to start out with a bunch of written directions simply because written directions can be a challenge for a lot of students who can otherwise do the mathematics just fine. Okay, so, but we understand the pictures, then we understand the written directions. Okay, now. I'm just going to say that what we've done here is center divide 3 steps both ways. Okay, now we just did what we did here for horizontal, but using vertical lines and using horizontal lines. So we have a nice symmetric picture. If we did this in a square, perfect square, and rotated it 90 degrees, it would look exactly the same as it did before we rotated it. Matter of fact, we rotated 180 degrees or 270 degrees, you know, through a quarter rotation, through a half rotation, 3/4 rotation, of course, through full rotation. It's not going to look any different. Okay, center divide 3 both ways. Then we start here. Okay. This is on the left edge, the line just below the center line. I guess I should write that start. So we start here and then we go over 1, down 1, over 1, down 1, over 1, down 1. And then we draw the curve. Another thing I should say about this one is the red dot goes at the center. Okay? And I will, I have written that out in instructions. Okay, so then we come up to the top edge and start at the point just to the right, on the line just to the right of center, and then over one, down one, over one, down one, and what we get has an obvious symmetry with this. Every point here is could be connected to a point down here, and we go through the red line. Every point here corresponds to a point down here, and the relative positions are the same in ways that I don't want to state right now, because I don't want to confuse things any more than they already are. Okay, and then start at the top, the line right of center. Over one, down one. And sketch the curve. Yeah, it's badly written for the curve, but you know what I'm writing. One thing we don't do is we don't connect anything on the left to anything on the right. Okay, now in my class, usually I'll have people draw the squaring curve or the squaring shape or the exponential shape. And this is what we call the toolkit squaring shape. SQ being abbreviation for squaring. I'll write that out, write the whole word out. I want to abbreviate when I post the instructions. And this is the toolkit reciprocal shape. All right, usually second day, I'll have introduced one of these. Usually it's been the squaring function. I think in the future, I'm going to start with the exponential function because it's easier to draw. And you still get the idea of following instructions. The instructions are easier too. So, hindsight, I prefer that I'd already done that, but it didn't. Okay, anyhow, there's your toolkit reciprocal shape. Simple enough. Now, without writing much, I'll have more board behind me. Okay. Okay, we'll use this. Let's see. Need to come over this tab. They don't go off the board. Okay, so we're going to do two more. And I'm just going to sketch them without comment. Well, I'll comment, but I'm not going to write anything down. I'm just going to say what I'm doing. But you should be able to understand what I'm doing. Okay? If you've understood what we've done so far, then this will be easy. And if you haven't, then I recommend that you go back and draw each of those shapes several times until you don't need to look at the instructions and you don't need to look at a graph. At least right now, if you have time, and if not right now, within 24 hours, do this. At least be able to draw these things without having to look at a picture or look at instructions. Then, by the time you're going to be quizzed over it, be able to draw each one in 2 minutes or less. Okay. Now, here are the last two of the main ones. There are others that are very important, and two of those are very, very simple, and I don't even mention them in the context of these. Okay, so this will be the toolkit. reciprocal square shape. Okay. Let's be specific about the red dot. It goes in the center of the lower edge. We divide here, divide each half toward the center. Then we divide each rectangle toward the center. And there we have it. Okay. Then I kind of lied to you before, but we'll see. Then I'm going to center divide. Center divide with vertical lines, 3 steps. I said I wasn't going to write anything. I think we get away with 4 steps, center dividing horizontal. Okay, so, oh, wait a minute, never mind. One line. That line is being bigger. Okay, we divide this the same as we do for the squaring function. It's a typical square, but it's going to work regardless. Okay, so there's one. There's 1, 2, 3, 4. It turns out it only needs 4 steps. It's not exactly the same as the way we center divide the squaring graph. What I said was incorrect. We don't need the 5th line because we're not going to go any closer to the bottom. Okay, so what we do is we start here. This would be the same point we would have used for the exponential function. And then we go over 1 down 2. I'm writing down more than I want to, but left edge. First line above the lower edge. Same as for the exponential function. Then over 1 up 2. Well, we go over 1 up 2. Over 1 up 2. And that's it. If we try to go over 1 up 2 again, first of all, we need 1 more line here, then we need more lines up here. We don't have them outside the rectangle. Doesn't mean we couldn't make such lines. Not real fond of this, but there it is. Okay. Yeah, it's gotta be right. So then we start 1 line to the right of the center on the upper edge. It's going to be symmetric. Okay. And then we go over 1 down 1 and over 1, sorry, over 1 down 2, over 1 down 2. And we sketch. Yes. And it's nice and symmetric. So that's it. And again, we don't connect left to right because the process would continue. We go closer, we go higher. We'd actually go 4 times higher each time we go over a line. And these lines are all subdivided, so there's an infinite number of them between here and the center line. So we go up 4 times as high an infinite number of times, we get really high, really fast. That's worth storing away if you understand it. If not, just right now, learn to do this. But the more you understand, the better you're going to understand things later. So it's kind of worth thinking about the things I'm saying, as well as what I'm doing. Okay, now I said we're going to do 5 of them. We're going to do the cubing shape. And I really want to do the cubing shape in an extended rectangle that's not square. Okay. All the others work just fine in a square. They work just fine in just about any rectangle. As long as it's got enough width and enough height. Okay, now keeping function here. All right. There's a red dot at the center. It's a little to the left of center. Can't seem to get that right. Okay. So we're gonna divide it. The same as all the other graphs. Except for the exponential. Remember with the exponential. We don't need this last pair of lines. We just need this, we get this one, and then we get these two. That's all we need. We'll see why that is. It's because if we did another line, we get something that can't be computed except approximately. Everything else can be done exactly. And hopefully that should stimulate a little curiosity. For most people, it doesn't. And it's okay, just learn to do what we're doing. All right. So now we center divide. Okay, I'll say center divide vertical 3 steps. Then we center divide horizontal. Okay. Now I'm going to do this before I say how many steps, but it's a bunch of steps, which is why we want to make this kind of elongated. So we horizontally, we sketch a line halfway between the top and the center, and then halfway between the bottom and the center. That's one step. Next step, we divide each of the rectangles we form toward the center. And here's the second step. Now this gets out of hand, but there's a lesson in the way it gets out of hand, so there's a reason that we go to all this trouble. And then we go a third step. Then we go a fourth step. Okay, so let's do one. Then we go a fifth step. This is getting pretty dicey. And you might not be able to see it too well, but you should be drawing these. You know, again, when you're watching a video, if you're in my class, or if anybody who's watching this video, because they're available to anybody in the internet, if they're fool enough to watch. The way to digest this is you kind of drawing these pictures as we go. Engage yourself rather than sitting back staring. Although if you're absorbing it all in a way that you know you could go away from the computer and do perfectly a month later, and some people have that kind of mathematical aptitude, that kind of memory, then that's fine. Okay. So somewhere on the level of engagement, most people that come into my classes need all the level of engagement they can. They should actually be stopping to draw these when they see them. Okay. Okay. But it's, you know, I can't supervise. I can't see what you do. If you're in my class, all I can see is what you can do when you come into class. And all I need to see when you come into class is that you can do these quickly without reference. Okay. So, you know, there we have it. Now, our rule is we start lower left, and we're going to end up in the upper right. And if you follow the rule, you got to end up in the upper right. And you go over 1 up 3. Okay, now, when I said we've got all the lines we can draw, it doesn't mean we've got all the lines that are there. So we go, let's see, how many steps was it? There's 1, 2, 3, 4, 5. Then we go 2 more steps, but we really can't. Unless you got a really good sharp pencil and a really big piece of paper, you're not going to be able to get 2 more in there. They're going to get so close, you're not going to be able to draw them accurately with any kind of accuracy. You're not even going to be able to see them if your picture isn't pretty big, at least the last one. So I'm going to say 2 more. vertical. Okay, so after this last line, there are two more lines on each side. I'll say two more invisible lines on this side of the center. Let's make sure we know where the center is. Let me make the center a little clearer. Here's the center line with the line real close below and the line real close above. And then there are two more invisible lines squeezed between these two very close lines. Above, meaning above center, and two more invisible lines below center. Now we can do this. Okay, so over one, up three. So we go over one, up one, two, three. That takes us all the way up to here. We're already getting really close to that center line. Then over one, up three. Well, we go over one and we've got one, two. Uh-oh. Did I draw enough steps? Yeah. We got 1, 2, 3, 4, 5. One. Either I'm not seeing the line or I'm missing it. 1, 1, 2, 3, 1, 1, 2. Oh. Looks like I can't count. It looks like we've got a center divided through 6 steps, then 2 more. Okay. So we've got another line in here that I haven't been able to draw because it's so close, but if you've got a good pencil, you're going to be able to draw it. Okay. So we go over one, up 1, 2 lines are there. There's a third line, and it'll be really, really close to the center line. Practically on the center line. And then we need 3 more invisible lines. They're really going to get invisible lines. Okay? Because if we go over one, we want to get up to the red dot. And the red dot, that'll be. No, we only need 2 more invisible lines. Okay. We go up 3 lines. Sorry, I got confused easily. Okay, from the center line, well, from the center line, we go over and up, skip a line. That's the 2 invisible lines that we skip. Then we land on the last line that we drew, the 6th line we drew, and we subdivided. And that's why we make this thing pretty long, because otherwise we don't get the right shape. It's hard to get the right shape. So this is practically on the center line. Then we go over 1, and now we can see them up 1, 2, 3. What? I must have missed a line because we only go up here. Well, all the lines are there like they should be. We go over to them. Because this will be symmetric with this. Not too hot. I can't even see all the lines I drew, and neither can you. Just draw them. And then we go over 1, up 1, 2, 3, we get here. Now, see, I accidentally put a point there, and I'm not just to do that just to show you what can happen, although it does show you what can happen. I honestly did it. I'm just being a little careless, and you probably will be at some point too. It was going to work out. I tried to go over 1 and up 3, and I only had 2 lines above it. Then I knew something was wrong. I took 1 look, and that's out of sight, out of line. Okay, so something's wrong here, but this would be the direction, and if you do it right, it should work. Then we connect with our smooth curve, and you see how that smooth curve tends to really flatten out near the center line when we draw it on this scale. That's the way the cubic function looks. Now, one reason we're doing all this is I ask people to draw the shape of the cubic function. Just a freehand shape, and then they put a point here, and then they'll make it look like this. Oh, not quite that bad. They'll come up here and then they won't quite flatten out. They give me a shape like this. No, the shape really flattens out, and that's really important. For reasons that you won't appreciate until you take a calculus course, but it's really important for understanding things about derivatives of power functions. And for being able to see the way they behave. Also in this course, for being able to do a decent job of sketching rational functions. I'm sorry, polynomial functions and rational functions. Okay. Well, those are your basic shapes. And you know, in my class, we have a 30-point quiz coming up where people are going to have to draw these. Okay. I might choose to exclude one of them, but I might not. Okay, so I'll give people a 10-minute quiz, ask you to draw all these shapes. Now we can put numbers in these. We can then understand some really important rules of arithmetic by putting numbers in these shapes. The numbers that fall out of these shapes tell us what the rules have to be. So these rules, these pictures, in many ways define a lot of arithmetic and a lot of algebra. We haven't put any numbers on anything yet. The alternative is start with numbers and do calculations that you have to use your calculator for, so you don't understand the calculations. I mean, some people don't understand them all, but most of an incoming pre-calculus course in this region, people just don't understand it. Don't understand the arithmetic well enough. And I think that's pretty much true in most regions of the country. Okay. And I think a lot of it has to do with COVID. It's not bad teaching. I don't think the curriculum is designed as well as it could be, neither is anybody else. But I'm glad they don't ask me to decide it because I don't know what we end up with. Okay. So there we are with a quick introduction. I'm going to continue then with another video that shows you where these shapes fit in to the rest of the course. Okay, I want to talk just a little bit about how we use these things, these basic toolkit shapes, like these that we construct, as I've demonstrated in the preceding video. What we do, say we want to use the exponential shape. Okay. We can construct the exponential shape between two pairs of lines, one pair horizontal and one pair vertical. Let's just say this is x equals A, and this is x equals B, and this is y equals A, and this is y equals B. Now the exponential shape's a good one to use here. So I construct the graph, and I've explained how to construct it, so I'm just going to construct it. And you should be able to construct it as quickly as I'm doing, because I have to keep turning around, reaching for chalk and waving my hands, because I got a gesture when I talk. Okay. It's sort of just over here. Block it, that's that over there, so it doesn't distract. Okay. So here's my exponential. Now your video will show you how many seconds it took me to do this. If you click back to where I started, and then to where I finished the curve. There's the function. There's the exponential function. Okay. Now, this point here, I'm going to say has coordinates H and K. On a set of coordinate axes. So you got an x-axis somewhere and a y-axis somewhere, okay? This graph might be so far from the x and y-axis that you can't get it on your paper. It could be so far from the x and y-axis that you can't get it onto this football field, okay? Or onto this planet. It could be anywhere. A and B could be really big numbers and it's not, that's y equals C and y equals Z. I want to use different numbers here than here. Okay. Now, another thing. I'm going to call this dimension here the width. It's just B minus A. I'm going to call this here the length. Okay. Now, there's an equation for this function, and this gets us immediately into some algebra. Okay, the equation and the graph of this thing, this function is y equals g of x, where g of x equals this for some number A that's really easy to calculate in the length and the width. I could tell you how, but you're not going to worry about it. There it is. It's an AF of x minus h plus k. For f of x is 2 to the x. It follows from function notation g of x, not g of a. I'm thinking ahead of what I'm going to write next. Okay. G of x is what? Well, actually, I want to do g of x first. So I'm going to say, first of all, we're going to say if f of x is 2 to the x, then x minus h is 2 to the x minus h. That's just substitution. If you've had algebra courses, you know about substituting. If you haven't had algebra courses, you better not be in a pre-calculus course just yet. Although a lot of the stuff you can do. But as soon as we start doing a little algebra, it's going to get away from you. Okay. Most likely. But you know, even if you haven't had algebra, you see that if I replace x here, both here and here, with x minus h, then I get the formula for f of x minus h. If x is replaced by x minus h, I get f of x minus h. And if I replace the x here by x minus h, I get 2 to the x minus h. That's all there is to it. And once we see that, I think maybe I can sneak this in down here. Got a longer piece of blue chalk. It's easier. There we go. So I'm going to write this pretty neatly because it's pretty, you know, g of x equals a times 2 to the x minus h. Plus k. Now why? Because g of x is big A times f of x minus h plus k, and f of x minus h is 2 to the x minus h. So all I've done with this expression is replace f of x minus h with 2 to the x minus h. Let's just kind of quickly indicate our substitutions. X here has been replaced by x minus h, which literally gives us this. And then the f of x minus h has been replaced by what we just got when we replace these x's by x minus h, 2 to the x minus h. Okay? So y equals g of x equals A F of X minus H plus K equals A times 2 to the X minus H plus K. Now, if we know the coordinates of the red dot, which means if we know where this thing is, and if we know the width and the length, which determine what A is going to be, in a way, in a very, very simple way, I'm not going to even mention it, I don't want to confuse it that far. We have a formula into which we can plug the value of X and find out what the value of Y ought to be, so that if we have a line here, let's say this line is X equals, oh geez, I'm out of good letters to use. We'll say X equals N. Now, N usually stands for an integer, and there's no reason to think that this is an integer like a whole number or a negative whole number. Okay, if we have X equals N here, then the point we get on the graph is here. And there's another line that goes through this point, and this is Y equals G of N. And all this means is, whatever the value of N is, we replace X with that value. If we got a number for A, a number for H, and a number for K, then we can take our calculator and figure out what this is. And for an exponential function, usually you're going to have to use a calculator to evaluate it. Okay. Now, geometrically, what that means is, if you have the point on the graph where X equals N, you can draw this horizontal line and estimate what the Y coordinate is here. How do you do that? Well, we know what X is here and here, so we can figure out what, okay, these three vertical lines divide the rectangle into 4 parts so that H is halfway between A and B. Well, if you got easy numbers, you can easily see what's halfway between A and B. That would be your H number. And K, you already have it. K is equal to C, whatever the lower Y number is. So if I give you numbers for A and B and C and D, you can figure out what H and K are. And you can figure out what the equations of all these lines are. We do examples, but right now I'm just kind of giving you the overview. And then we've got these horizontal lines. We can figure out from the values of C and D and how far this is, what the Y value here would be. It'd be halfway between C and D. And then the Y value here would be halfway between C and whatever this Y value is. The Y value here, halfway between C and whatever this Y value is, and so forth. We can label these lines, and we can then have a scale on the graph, and we can kind of figure out and estimate what the coordinates of this point would be. Okay, so go through the details of that, and people don't have a lot of trouble with that. So that's kind of where we go with it. Now, if we are given Y, okay, so let's say we have a line here, or Y equals M. Again, M and N usually are used to refer to integers, but I'm kind of out of good letters when I've used A, B, C, and D here, and G and F here. I don't have a number between D and F. I don't have 2 letters between G and F. And then after that, we got H, which we've already used, and then K comes along. So I'm having to use M and N here, but not too standard. Okay, you got Y equals M. we got a point here, we can draw that vertical line. And if we know what numbers go here, 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 and here, and we do, if we know what A and B are, and we can figure it out, then we can figure out this number here. And this number, we'll extend this a little lower. Okay, this line goes through, but we don't have to draw both of them. This is a solution of G of X equals M. If this is completely accurate, and we can estimate that solution. We can also solve the equation. G of X equals M means that A times 2 to the X minus H plus K equals M. Well, if we have numbers for A, H, and K, then that's an equation that we can solve if we know how to solve this type of equation. Now, this isn't the type of equation that you're going to know how to solve unless you've had a pretty good high school analysis of the calculus course already. Okay, and learned how to use logarithms and stuff. So we learned to solve this equation later in the course. Okay, so and we don't have the skills to solve this equation if we come in with just the basic prerequisites from pre-calculus course. Okay. Now, other equations that we can get. If we have a squaring function. And I'll construct that as quickly as you need to be able to construct it. We're using it in class and need to move on. As accurate as I'd like. But this will do. Let's put our red dot in here. Let's now walk up points. And sketch. A half decent graph. I'll go with half decent that number. Okay. And this is X equals A. Y equals C. Y equals D, whatever these numbers are. We can easily figure out the width and the length, and if we then know coordinates HK. Again, if this is a graph of the function G of X, we say Y equals G of X. Once again, G of X is A f of X minus H plus K. And all we need to know is the values of A and B and the values of C and D, and we can figure out both A and H. I said both A and H, both H and K. K is automatic. We know Y, the value of Y here. If we know what C is, that's K. H is halfway between A and B, just as it was over here. Now, you don't have to do the details of this, but we're just giving you an overview of what's coming in the course and the things you're going to learn how to do. Now, if you have a sufficient background and learned it well enough, you might understand everything I'm telling you. Otherwise, just trying to give you an impression. Okay, so this time. F of x equals x squared. So what do we think f of x minus h is? Well, I kind of explained it over here. If you picked it up well enough, you might be able to tell me, and it would be a good idea to just stop for a second and think about it and see if you can do that. If you can't, no shame. We do it more slowly in class. Okay, f of x minus h would be just x minus h squared. In other words, f is a rule that does to what's in parentheses, just what f does to x in parentheses here, meaning it's going to square it. F squares whatever's in parentheses. So if the x minus h is in parentheses, we get x minus h quantity squared. That's worth pondering that. But again, I don't expect people to walk away from this video knowing that and being able to do that like on the quiz or something. If you think about it a little bit, you're going to recognize it next time you see it, which should make it easier to learn. If you already know it, that's great, but that's not necessary at this point. Okay, so f of x equals x squared, f of x minus h equals quantity x minus h squared. And then okay, so there's your g of x. Again, all you need to do to fill in the a, the h, and the k, that gives you a perfectly good formula for this curve at this location in the xy plane is value of h and k, the width and the length, with a length to width ratio, turns out. So if you know the values of x here, if you know the equations of the two lines above and below, and the two lines to the right and left, then you have everything you need to write this function. And then we can solve this equation. We can verify any point on this graph. We've got a point here. Got value of x here. Have a point here. We have a value of y. Now I haven't put what x equals, but now if we take this number and put it into this formula and take our calculator and figure it out, well, if the numbers are easy, figure it out by hand. You know, should do that if the numbers are feasible. It can be quicker than using a calculator. Anyhow, you need to think about the arithmetic sometimes. But you know, if the numbers are weird, you're gonna have to use a calculator to do a lot of this. But there's the function. Okay. Now we can do similarly with any of the other functions. I'll just list the form of the other functions. Just like we have a times 2 to the x minus h plus k to the exponential. And you know what I wrote here? I wrote a times x minus h plus k, which is, of course, true, but that's the same as what I wrote up there. And I did the same thing up here. So let me fix that. And my apologies. This should be a times x minus h squared plus k. Replace this x minus h with this f of x minus h with this expression for f of x minus h. We'll do the same here. Wrote those down without thinking about what I was telling you. Okay. Anyhow. That would be for the cubing shapes. If we did a cubing shape, we determine A, H, and K, the same as we would do for any other shape. If we have the reciprocal function, it'd be A times one over X minus H plus K. If we have the reciprocal square, it's A times one over X minus H squared plus K. And we'll see why these are the forms of those functions. Okay, so we can immediately move over into quite a bit of algebra and where we learn to solve equations like this one later in the course, but the equations that we get here, we're going to be able to solve just using basic algebra that everybody should already know. If you're rusty, that helps us to review the algebra. Okay, so this is a connection between these shapes and the algebra. I'm going to talk in the next video about why these things are important.